Numerical integration, our objective is to program the trapezoidal rule algorithm. So here I start. Okay, so import numpy as np. So we may require the mathematical function, and after that I define a function. So define f of x, and for the time being I'm going to take the function 1 minus x squared, and I will define this function between 0 and 1. Integrate between 0 and 1. The problem is integrate this function, integrate f of x from 0 to 1. Right. So function definition is there. Then now I'm going to write in the form of a function. Right. So define trapezoid or trapezoidal rule. So it must have the arguments function, the limits a, b, and a definition of n. Right. These are the input variables we have agreed. So having the definition of a, b, and n, we can define h, which is equal to b minus a over n, right? And then let's define the other variable, integral. So integral is equal to 0, the first value, right? It is just like summation for the computation of summation. And then I specify integral equals the first two terms. I say it is equal to f of a plus f of b, and divided by 2. So values have been defined. Now I have to compute the terms in the summation, which is over here, right? So I have computed f of a plus f of b. Okay, let's make it consistent with the formula written in front of you. So f of a plus f of b. Now for the summation, I write for I in range 1 to 1 to n. Of course, it is going to miss the end point. It is from 1 to n minus 1 practically, right? So that is consistent with the Python convention. So I define a value x. So x is equal to a plus I asterisk h. So to avoid any kind of confusion, I first define x equals 0 for I in ranges. And then the next step is to update the integral. Integral is equal to integral the previous value plus the new value, and I make it multiplied with 2 times f of x of 2 times f of x, right? And that's it. This statement is basically equal to the convention statement, integral equals integral plus 2 times f of x, right? So these are equivalent expressions, and that's it. So this summation is over, and then after that, with the computation of inner structure, with the computation of this sum, we have to multiply it with h, and okay, this has not been converted. This is being considered as a text uh, type cell. So I add a code cell. Yes, should be a code cell. Yes, so in code cell everything is fine. To avoid the confusion, I delete this. So this is the trapezoidal form. The n corrections, now we require only the integral equals integral times h by 2, right? So h has been defined, h star integral, or say divided by 2.0 times integral. So the value has been updated. The final factor h by 2 has been multiplied, and now uh, this is the end, and with the end of the function I can say okay, this is end, this is over. So function definition separately in the upper cell, and we have the trapezoidal algorithm which requires function, the limits a b, and the number of intervals have been specified. And let's add this function to the library, and now in the next line we are going to call it. So for example, I write trapezoidal, and function is f, limits are from 0 to 1, and say for 10 intervals, right? So a b and 10 intervals. Some error has been returned, f is not defined, so maybe I forgot to run that cell. Okay, so run this cell. Okay, this has been executed correctly. Then run this cell, and now this execution will be successful. Let's hope. Well, the answer has not been returned. So I write here a print statement, print trapezoidal. Okay, well, I have missed a statement here. What my function should return, right? So return the value of integral, integral. So now again, run this one. So we have got the answer 0.6649999, right? So the integral was from 0 to 1. Its exact answer, if I write, so exact answer is uh, is 1 minus 1 by 3, right? So you can readily compare it. So we have the computed result and the exact answer. We can change this one, say for example 20. So accurate up to 3 digits, right? So this was the trapezoidal algorithm. So I hope you on similar lines you will be able to develop algorithm for Simpson's one third and create rules.